Hi everyone. So I'm back again with another model drop video. Anthropic just released Claude Opus 4.5. We've had access to this for a little bit, so wanted to get my first impressions on it. I think similar to the Gemini 3 video, leading here with the benchmarks. I think across the board, on these public benchmarks, also what we've seen internally, Opus 4.5 definitely better than Sonnet 4.5 on a lot of these. Sweet Bench Verified we looked at with the Gemini 3 launch video. Again, you know, Gemini 3 Pro is here. I guess in this evaluation, Sonnet, this was the only benchmark actually that Sonnet 4.5 or Gemini 3 was not better than Sonnet 4.5 at, and Opus 4.5 significantly better than Sonnet 4.5. I think the most significant thing though is the pricing. So Opus 4.1 was $15 per input token, and Opus 4.5 is 3 times cheaper, $5 per input token. So for reference, Sonnet 4.5, $3, Gemini Pro or Gemini 3 Pro, $2. So Opus 4.5 still significantly more expensive than Sonnet, but 4.1 was just so expensive. I mean, it was $3 for Sonnet versus $15 for Opus 4.1. I think the difference is kind of crazy. So I don't know if very many people used Opus 4.1 in practice, just because it was so exorbitantly priced. Opus 4.5 actually is like within range of Sonnet 4.5. So I do think people who are not so price sensitive and are on like API pricing, for example, or if you're using the max plans for coding, I think I wouldn't be surprised if a lot of people start using Opus 4.5 instead of Sonnet 4.5. Okay, so in our own benchmarks, so you can see here, Opus 4.5 better than everything else for GPT 5.1, GPT 5.1 codecs, Gemini 3 Pro, Sonnet 4.5. This benchmark in particular is measuring file system use. It's basically, so this is part of Context Bench. Context Bench has two components. It has both a file system eval and a skills eval. So how well can models load and remove files from their own memory? So files being like PDFs or other things you like load into the context. And for skills, it's similar. Basically, how well can agents discover skills that are relevant to them, that are sitting in a local directory or local file system, and then how well can they actually like load them into context, and then also unload those skills. So in both cases, Opus 4.5 is significantly better than Gemini 3 Pro. Actually, in the skills one, Opus 4.5 is not better than Sonnet 4.5. Sonnet 4.5 is still better. But yeah, in the file system benchmark, Opus 4.5 clearly at the top above Gemini 3 Pro, GPT 5.1, both the latest releases, and also its predecessor, Sonnet 4.5. Yeah, so in terms of the actual model performance, I think, like I said, the benchmarks that we're looking at, clearly better than a lot of these benchmarks than Sonnet 4.5 or Gemini 3 Pro. Gemini 3 Pro itself, like I said in the video, it definitely is what I call the benchmark crusher, extremely good at benchmarks. But then when we actually used it in practice, it was definitely better than Gemini 2.5 Pro, but it definitely felt a little worse in the experiments that we were doing than Sonnet 4.5. So I was also reading Simon's blog on the Opus 4.5 release, and I actually think he made a pretty good point here. I think this lines up pretty closely to my own experience. It's clearly an excellent new model, but I did run into a catch. My preview expired at 8 p.m. on Sunday, so basically, the early access expired, and then he had to switch back to Sonnet 4.5. And basically, he said that like once he switched back, it wasn't really clear that he had regressed, or like it wasn't clear that working with Sonnet 4.5 was significantly worse than working with Opus 4.5. But yeah, Opus 4.5, in some ways, if you had blindfolded me and swapped out Sonnet 4.5, I think in many cases along kind of my coding trajectory, I wouldn't necessarily have trusted myself to have been able to tell the difference. Okay, so the Anthropic team also put together a prompting guide. I think the most interesting part of the prompting guide was kind of about this tool triggering. So Opus 4.5 being more responsive to system prompts. So yeah, basically if you had old system prompts and part of your system prompts had stuff like critical, you must do this, or like never do this, I think, they're kind of at least suggesting that you should dial back this language. So take out the all caps. So instead of saying, critical, you must use this tool, just say, just use this tool. Okay, one other like technical difference when you're actually using the model in the API is that Opus 4.5 now has an effort parameter. So previously when you're using Sonnet 4.5 or any of the models that have reasoning in them, so that would have been Sonnet 3.7, Sonnet 4, Sonnet 4.5, Haiku 4.5. you basically would specify a maximum number of reasoning tokens. Okay, so what this looks like in Letta, for example, is if you have the model up, the way you control like whether or not, well, firstly, you can disable or enable the reasoning. So you can disable it, re-enable it. So this is basically turning on and off extended thinking in the API. But the way you actually control like how much the model reasons is you would set this maximum reasoning tokens. So by default in Letta we set it to 1024, but you could kind of like crank this all the way up until 8192. So you could basically have the model spit out have like a target set for spending 8,000 tokens on reasoning. So this is kind of like going to get the model to think a lot. 8,000 is a ton of tokens. Versus if you set this to like 1,000, it's like a low, medium, or lower or medium reasoning skill. Okay, so this is in contrast to OpenAI. OpenAI instead with the GPT-5 lineup, they basically have a reasoning effort. So instead of specifying the specific number of tokens, you would specify whether you want none, minimal, low, medium, high. So more of like natural language explanation. You would not set by specifying reasoning tokens. You would do it through an effort. So the big difference in the Opus 4.5 API compared to like, the Sonnet 4.5 API, I mean, all you need to do really is change the model handle, or like the model name. But the other thing you have to do is you need to use like reasoning effort. So you can see this basically looks exactly like kind of the GPT-5 style of setting reasoning. So instead of specifying tokens like 1,000 through 8,000, instead you specify levels. So in their case, in Claude's case, you specify either high, medium, or low. Okay, so that's a really quick overview of the kind of model release notes. I think the big things are benchmarks, pretty good. In most cases, better than Sonnet 4.5. The price, I think that's probably the biggest thing. The price is now 3 times cheaper. Instead of $15 per million output token per million input tokens, it's just $5. So it's compared to the $3 for Sonnet. So it's not quite twice as much, but it is significantly less than Opus 4.1. So it's like definitely much more usable. And the effort param. So if you are going to use this in your API and you want to control the reasoning level, instead of setting like reasoning tokens, you would set the effort param. But I think the more interesting part of the release was actually this blog that they had on advanced tool use that they released alongside of the Opus 4.5 model. So these are what they're calling like 3 new beta features inside the Cloud Developer Platform. I think a few of these, I wouldn't necessarily say they're like brand new ideas. They've existed in other work, kind of like MCP as code, CodeAct, and other stuff for a while, but I think they're kind of getting polished and a spotlight is being shown on them through this blog. And I think these are all also not necessarily techniques that are like specific to Claude. These are things that can be put into like any sort of agent platform or any sort of agent harness. So I wanted to go over these because I think these are actually in many ways a little bit more interesting than the model release itself. Okay, so the first thing is kind of a tool search tool. I think this is like a pretty common thing people complain about in MCP land. I think if you are a developer and you're using some sort of client like Cursor or like Claude Desktop that you connect MCP servers to, I think the default these days, so not inside of Letta, but like the default on a lot of platforms is you connect an MCP server and then like auto attaches all the tools. Okay, so in Letta, for example, you can add MCP servers because it's an MCP client. So if we chose one like this Deep Wiki server. Okay, so this Deep Wiki server, it basically exposes 3 tools. So it's not that bad. It exposes read wiki structure, read wiki context, ask questions. But in Letta, when you like add this server, it doesn't auto add all of the tools. It actually like auto adds none of the tools, and then you have to go in and kind of attach the tools independently. So the reason we do that is exactly the problem that Anthropic is describing in this blog. Basically, that server I just showed you, it only has 3 tools, so it's kind of closer to like the Splunk server or the Sentry server. But a lot of these MCP servers, they have a ton of tools. So like the GitHub MCP server, for example, it has 35 tools. And I mean, 35 tools is pretty crazy. Like the Claude code harness itself, I think has, it fluctuates, but anywhere between like 10 to 15 tools. So that's just like the base tools. But then if you add like, you're using Claude Code, then you add the GitHub MCP server and the Claude Code harness, like auto attaches 35 tools. I mean, you're quickly in the territory of like 40, 50 tools. And yeah, I don't really know of anyone running agents in production with that many tools attached. They're actually, actually using the tools very well. So it's not only just having a ton of tools, but I think it's also these tools themselves, like the schema of the tool. So the definition. So yeah, hopping back over to Letta, you can kind of see each of these tools. If I were to attach it to the agent, so I attach this read wiki contents, the tool to the agent. Okay, so I go back to the agent, open up this tool. So this JSON schema, just for this simple tool, and all this tool is doing is it's reading wiki contents, and then you have to specify like a repo name. This tool has like a ton of JSON that is required to kind of like describe to the LM how to use it. And this is going straight into the context window. So you can see this agent I have set up here that I just started kind of from scratch. It basically has nothing attached. The system prompt itself is taking 341 tokens. The tool descriptions are taking, just with 3 tools, it's taking already 1,900 tokens. So almost 2,000 tokens for 3 tools. And you can imagine, in a lot of these cases, like the agent only has 200,000 tokens of available context. So 2,000 tokens, you're talking about like, a very significant portion of the context window, like 1% of the context window. So the example they're giving here, it's kind of ridiculous, but I've definitely seen this before in practice. Someone will have like cursor set up, and then they will attach 5 different MCP servers. And in cursor, when you attach the MCP server, it's going to auto attach all the tools. So very quickly, if you're using Claude inside, like Claude Sonnet 4.5 inside of cursor, you already have 55,000 total tokens out of your 200,000 tokens dedicated to tools, right? And like this agent doesn't need to see all of these tools at any given point in time, right? Yeah, so they're kind of saying here the same things that I was just talking about. Basically, you have both token cost. So basically, like these are taking a ton of space in the context window. You have to pay for those input tokens. But the other thing that is pretty common, I think probably is the bigger problem, is just when you have this many tools, the model is just going to fail to select the right tool at the right time. It's going to get confused. It's going to like miss tools and not see them properly. And yeah, Anthropic here is calling out that when tools have similar names, this is kind of a particular thing that can trip up an agent. Okay, so what is the solution? Kind of a meta solution. I've definitely seen this a lot of places before, but it's cool to see it implemented directly into Claude, basically a tool search tool. So you can have a tool dedicated to searching for tools. So basically, by default, the agent might not have any of these tools attached, but then if it knows that it can use GitHub, so that it might search like, hey, what is the tool I need that is going to allow me to publish a new PR in GitHub, and it will call the tool search tool, and that will retrieve the GitHub tools into context. And I've seen this done a bunch of different ways. You can imagine retrieving just a single tool. You could imagine retrieving all of them. But basically, these tools now get attached into the payload of the LM. And what I mean by payload is Anthropic, when you call Claude, and this is the same for ChatGPT or for the GPT models or like any of these other inference APIs, it's the same thing for Letta. Basically, when you call the API, you specify ahead of time like what tools are available, and then the agent might return a tool call message, but the tool call message will only pick from the available tools in the payload. So basically, in the standard setting, this tools field is stuffed with 50 tools, 60 tools, taking like 50K, 100K tokens, whatever, something really, really big. And what's happening now is like this actually can start empty except for one tool. That one tool is the tool search tool. The agent can then call the tool search tool. That will return, in the next turn, it'll make sure that this tools array, when sent to the model, now has more than one tool. It now will have like both the tool search tool and then also some other relevant tools. Okay, so how do you actually implement this in practice? Back in the API spec that I was showing you earlier, in that tools field, you basically will just like mark tools as defer loading. And if you mark them as defer loading equals true, okay, so basically in this payload, you actually do attach all the tools. So the tools array might have like 50 or so, it might be like outrageously large. But you mark these tools with defer loading equals true if you don't want them to actually be visible to the language model Claude on the initial run. So basically, Claude will have to run like an additional step to discover these tools. So obviously, there's like latency concerns here to a certain extent because you now not only have to like run one LM call to basically decide to call the tool, but you might have to run an additional LM call to like discover the tool. But it saves you a ton of context, especially if you have this issue where you have like a ton of MCP servers, a ton of tools. I think in many cases when this is happening, my general advice is to actually just limit the amount of tools you're attaching. But I do think there are some cases where, let's say you filter down this list as much as you possibly can, and you only get it down to like, let's say 30 tools. I think 30 tools on top of like Claude Code or some other harnesses like 15 to 20 or 10 to 20. I think that is a lot. So I could definitely see this being pretty valuable there. All right, so the next feature in this advanced tool call features list is programmatic tool calling. Okay, so this one I think is pretty cool too. So I think one of the first places this idea like really became popularized in is in this CodeAct paper. Yeah, so the CodeAct paper is basically saying, the standard here, the standard with like function calling ever since OpenAI introduced it back with the like GPT-4, GPT 3.5 API with back when it's called function calling, now it's called tool calling, is that the LM agents, they take actions by outputting JSON. And I think there have been some attempts to try to like use other, forms of output where you can use like XML or like some more like efficient things than JSON or like YAML. But basically, the industry is standardized on JSON. So yeah, this is basically the status quo. Like Claude, GPT-5, like all of these models, they are outputting JSON, and you are also like that's the reason you input JSON. You input into the API a bunch of JSON schemas, and then the LM agent can kind of like pick from the JSON schemas and kind of call a tool by writing out JSON. So the CodeAct paper is basically saying that this is pretty inefficient. It's pretty inefficient to ask an LM agent to call tools individually through JSON. Why not just allow the LM to write everything in code? So you can basically tell the LM, hey, there are these subroutines available to you. So instead of saying to the LM, hey, you have like tool lookup rates, you have tool lookup phone price, tool convert and tax, and you're going to have to like call these sequentially, or with parallel tool calling, call them in parallel, or some subset of them in parallel. Instead, all these tools kind of exist as code. So you can just write code, and we will, run the interpreter and kind of substitute all, the live modules in so that this code is executable. And you can see that this is actually like, in some cases, I think this is not more efficient, but in many cases, when you're trying to do very complex actions, this is much more efficient. So I mentioned parallel tool calling, right? So you might say like, okay, well, actually parallel tool calling, doesn't that solve kind of the efficiency problem? Because each of these is an LM call. Like you don't have to do many LM calls. You can just do them all in once with parallel tool calling. But parallel tool calling, it's quite naive, right? It only allows you to basically run things in parallel. It doesn't allow you to like compose these tool calls very well. Versus CodeAct, if you are able to write everything out as code, then the LM spends a single LM call to write out this code, and it can do kind of like arbitrary things. So it could do a loop in here. If your interpreter of the code that your LM is writing is like TypeScript, or if it's Python, it's Turing complete, so you can do all sorts of stuff. You can you can do parallel tool calling, you can do group parallel tool calling, all sorts of like compositions. So yeah, basically, this principle of, in many cases, it's a lot easier for LMs to write code, much more efficient than outputting JSON as tools. Okay, so CodeAct was published all the way back, at least the archive date here is June 7th, 2024. So something a little bit more recent that happened kind of in a post-MCP era was a lot of people were kind of saying, similar complaints about MCP servers, just like kind of polluting the context, because the default, again, I think people are using MCP a little bit wrong when they do this, but just attaching an MCP server and then dumping all the tools in the MCP server into the context window. So there's this thing from CloudFlare. So this one's a little bit more recent, 2025, so September this year, called Code Mode. So basically, they're saying a very similar thing to CodeAct, but for MCP. And the standard way MCP would work is it's basically very similar to tool calling. It's just kind of like privileged tools that are running on a server as opposed to on a client. But it's a very similar principle of you provide JSON to the LM, and you kind of like explain to the LM what tools are available on the MCP server via JSON. And then the LM also kind of writes JSON in order to invoke that tool. So if there's a weather MCP server, the LM might output in its formatted style. It's going to output some JSON that's going to say get the current weather, and then it's going to add the arguments location, for Austin, Texas. And then it gets the tool result also in JSON. Okay, so code mode from Cloudflare, it's very similar to kind of CodeAct in principle, in that you kind of just convert all of the MCP tools to natural TypeScript, and that allows like the agent to just write TypeScript. So similar to CodeAct, just write it, make it really easy for the agent, just let it write code. And then you, as the code kind of interpreter runner or like the code execution runner, you're kind of responsible for doing this remapping. So you kind of have to turn the code that the agent wrote into, or you have to like turn all the functions in there and dynamically link them to the MCP server. Okay, so back to the Anthropic blog post is a very similar idea with programmatic tool calling. Basically, uh, they're saying the challenges here: context pollution from intermediate results. There's inference overhead. So every single tool call requiring a full model inference pass. The same thing we were looking at with CodeAct, where like the left side of the figure, like 5 tool calls or something, the right side of the figure that was writing code and only did like one code block, and that code block itself called many functions, kind of remapping to tools. So much more efficient, one LM call instead of like 5. And yeah, basically they're talking about the same thing here. So in their example, they have 3 different tools: get team members, get expenses, and get budget by level for this like quote unquote common business task. And yeah, basically with the advanced tool calling feature, Claude can just write code. So again, very, very similar to CodeAct. So you can see Claude is writing code that invokes get team members. It also calls get budget by level. And this looks like, yeah, this looks like Python to me. But yeah, get expenses. So I think those are the 3 tools, but you can see that the 3 tools are being called in kind of a much more complex way than just like parallel tool calling or serial tool calling. This is kind of parallel tool calling because it's doing an async IO dot gather, and then this one is doing kind of like more complex logic where it's finding employees that exceeded their travel budget by basically taking the results of the tool call and then writing some kind of parsing code on top. So this would be the equivalent in like non-CodeAct or non-code mode or non-orchestration code mode. This would be the equivalent of like first calling the tool, getting the results, and then calling like a code interpreter tool or like an analysis tool with Python. So instead of like two or more steps, steps being like LM calls, this can all kind of get folded down into a single LM call. So definitely much more efficient to do it this way. Okay, so the actual way this works, I think is again a little bit complex, right? Because Claude the model doesn't have access to these tools. These are not server-side tools. Like in Letta, you can have server-side tools. So implementing this is much easier, and we'll have a separate video on that. But in Claude, like the model lives on the server, but then all these tools, so the get team members tool, the get expenses tool, the get budget by level tool, like Claude, the model or the API service, like once you get through the API barrier, they don't, the API doesn't know what the source code to execute that function is. So in order to actually interpret like a big block of code like this that has a bunch of, basically dynamically linked tools that don't exist on the server, you can imagine basically what has to happen is the client and server have to bounce back and forth. So like the server that is interpreting this code can only go so far until it like reaches one of these dynamically linked like client tools, and then it has to ask the client, to execute it and then return it back. But again, because the whole point of this is that Claude or like the model is only running once, it's more efficient. This doesn't mean that like you're hitting the Claude model many times, but it does mean you're hitting like the API many times. But there's a lot of like chatter back and forth between the user and the API. But yeah, again, one really cool thing about Letta is that you have both client-side tools and server-side tools. So if you're using server-side tools in Letta, all the tools, they actually live on the server, which means that you don't have to bounce back and forth to the client. So this sort of diagram to implement this sort of kind of CodeAct, code mode, programmatic tool calling, whatever you want to call it, it's much, much simpler in Letta because you don't have to like bounce back and forth with the client. Basically, the server could handle the entire interpretation of this programmatic tool call itself. But yeah, it's still definitely an advanced feature, so we'll save that for a separate video. Okay, so the last thing here is tool use examples. I'll go over this one pretty quickly because I think it's a little less interesting than the others. So yeah, tool use example is basically a way to provide additional detail, additional kind of in-context examples to your model to, in this case, like Claude, to basically try to teach it how to use complex tools better. So in this case, example is create ticket. There's like the input schema. So this is like the standard thing you generally provide. And then input examples are just like different examples of how to use a schema. So you can see in this case for create ticket, through the examples, we're showing like creating a ticket where the title is login page returns a 500 error. and then also a much shorter one that is just like for adding dark mode support. And you can see that like this one, has labels, feature request UI. This one has labels, bug. I mean, basically, like they're using different levels of like optional fields, and this is clearly a pretty complex tool, create ticket. So these examples, you could have previously put them inside of the description field for these tools. But yeah, I guess now you can also put them into like in a more structured way into an input examples field. So yeah, that's the wrap on Opus 4.5. Again, I think the Opus 4.5 release part is pretty cool. I mean, I think Opus is a great model. If you're not price sensitive, like I said, probably worth experimenting with daily driving. I think in my own personal use, also our benchmarks, clearly show it as being better. But in my own personal use, I think it's a little tricky to say just how much better it is. I think as with all of these model releases, we have to wait for it to sit for a little bit longer. But I think the really cool thing that I was excited to go over was this blog on advanced tool use that, and none of these things are particularly new, but I think both the tools, discovering tools, and kind of the CodeAct style thing, they're both like very, very interesting solutions that have been floated for a while on how to solve some of these context management problems. And yeah, so it's always cool to see kind of like new features around those ideas get built, and also just those ideas showcased in general. So yeah, hope you enjoyed. Thanks so much for watching.